Hello, welcome back to this channel. So today we are talking about trigonometry. We know trigonometry is the branch of mathematics that deals with the relationship between the lines of a triangle and the angles of a triangle. But we are going to talk about the general angle and the Pythagoras theorem. When we talk about the Pythagoras theorem, it means that we are going to specifically now deal with right-angled triangles. The right-angled triangle is that triangle which has the angle of 90. Which one of the angles inside that triangle is 90? And of course, we know if it has one of the angles equal to 90, all the other angles are always less than 90 for it to qualify to be a triangle. So specifically, we are going to talk about the trigonometric ratios in the first, second, and third quadrant. So a quadrant, we know a quadrant is simply a quarter of a circle. So when I have a circle, I divide it into 4 parts. So I have, this is the first quadrant, the second. So this part here is what we call a quadrant, a quarter of a circle. We all know that from our O level. So now we know the angles in this circle, they add up to 360. So each quadrant has takes on 90 degrees, which add up to 360. So we are going to see the behavior of these trigonometric ratios. That is the sine, the cos, and the tan. The behavior of these trigonometric ratios, the sine, the cosine, and the tangent. This we always call it tan, cos, then this is the sine. So we are going to see the behavior of these trigonometric ratios in the first quadrant, in the second quadrant, and in the third and fourth, and so on. So let us straight away go to the point. So we shall begin with the first quadrant. So if this is, let us say, first quadrant, if this is a circle, I think I should draw a better circle. Like that. If this is my circle, I divide it into 4 equal parts. So this is my quadrant. We know that if this is a point on a circle, let's say point P, X, Y. These points must satisfy the equation that x squared plus y squared is equal to r squared, where r is the radius of the circle. So the radius is just drawn from the center. This is r. This is my point, my length r. So it means that this is the x axis and this is the y axis. So it means that this point, I can say call it x prime and y prime. So if I try to extend this line here down such that it makes an angle of 90, so this line here is the y prime, and this point from here up to here is the x prime, and this line that represents the radius of the circle r is making an angle, say theta, with the x-axis. So if you try to observe these points, this y prime, actually it is the same distance from here up to here. That is the y prime. That's where we are getting the y prime. And this x, it is the distance just from here, like that. So we know along this line on x, x is always positive. And along this line, this upper part up to here, this y is always positive. So we know if this is the angle, we know that the cos of that angle, cos theta, cos, from Pythagoras theorem, we know that cos theta is adjacent over hypotenuse. The adjacent is x prime over the hypotenuse, which is r, the longest side r. And what is our sine theta? Our sine theta is opposite over hypotenuse, opposite y prime over hypotenuse. And we know that tan theta is always sine theta over cos theta. Or we know that tan theta is always the opposite over adjacent, or sine theta over cos theta. So it is y prime over x prime. So you see that from here, from this cos and sine, you see that this cosine is always positive. Positive. Why? Because the radius, if you talk about the radius of a circle, it will never be negative. That is obvious. So now the y that we are dealing with is positive. So it means that since this one is positive and this y is positive in the first quadrant, remember, it's the one that we are talking about. It means that the sign is always positive in the first quadrant. What does that mean? That from angles from 0 up to 90, which is pi over 2, whenever we take a sine of any angle in the first quadrant, it will always be a positive value. As simple as that. The same applies to the cosine and the tan and the tangent. What does that mean? So that this means that in the first quadrant, all trigonometric ratios are always positive. That is very important. We shall see the application of this when we finish this. We shall see how helpful is this going to be ahead of us. So now, and another thing I want to emphasize here, these points that we are picking on the circle, these ones must satisfy this equation. How? If I say that if I make x prime the subject of the formula such that x prime is equal to r cos theta and y prime is equal to r sine theta, square this and add. So I have x prime squared plus y prime squared. Sorry, this is your x. Yes, it is x prime squared plus y prime squared is equal to r squared cos squared theta plus r squared sine squared theta. Factorize out r squared, remain with cos squared plus sine squared, which is 1, which satisfies the equation. So those points must be satisfying that equation, since they are points picked on the circle. So they must satisfy that curve. So in the first quadrant, all trigonometric ratios are always positive. That is very important. So we can talk about the second quadrant. What happens for the second? So if this is my circle, this is my second quadrant, so I can draw my, sorry, I think I should start from here. My lines are not good, so you can try to draw good lines. So now this is the radius. We say this is the point on a circle. We can call it say can still call it x or xy, or we can call it x star, like that. So you see, that if this is the y and this is the x, so now it means that our x star is this length here. Oh, and this is the angle. If this is the angle theta, so it means that in some books you shall find that they are using this as the theta. Of course, these are alternating angles. They are always equal, so it doesn't matter where you put your angle. So now here, this is the same as x star, and this is the y star. You can call it y star, which is the same as this. So whichever route you follow, you shall still arrive to the same thing. So what is our sine theta? Sine theta, opposite over hypotenuse. Opposite over hypotenuse. So it is y star over hypotenuse r. But we have to bear in mind that our y is positive. We are still on the positive y axis. This length here is positive from here up to here. So, but on this side of x, we are in the negative part. This side, from this to this, it is always positive x. Then from this to this is a negative. So now cosine theta is equal to x plus x star over r. But remember, this is positive, this is negative, because of the x being on the negative part of x. Simply that. So now, what happens to our tan? Since tan is sine over cos, so we have a positive divided by negative. Of course, we have to have a negative. So the tan is simply the y star over x star, but the tan is negative. What does that mean? That it means that angles that are between pi over 2 up to pi, because we are stopping here at pi is 180, so these ones are not included, the pi over 2 and the pi. You have to be careful with my signs I'm using here. I'm not using greater or equal to. So angles between this range, say for example 95, any angle you can think of that is between 90 and 180. So now if we take a sine of those angles, it will be always a positive ratio. And the cosine of that angles, whichever angle you think about, so long as it is in this interval, it is always going to be a negative value. And so does too the tan of that angle. So let us go ahead and see the behavior of these ratios in other quadrants, in the third and the fourth and the fifth and so on. So let us talk about the third quadrant and we'll see what happens. So now we talk about the third quadrant. And by this time, you should be knowing the angles in the third quadrant. Of course, they start from pi up to 3 pi over 2. From 180 to 270. So this is our circle. And at this stage, you should be knowing the behavior of these trigonometric ratios before even we talk about it. So if this is my R and this is my point say Q and it is labeled XY, so if this is the angle theta made with the x-axis like that, so like that, in some books you'll find that they are considering this, which is also okay. 90 is here like that. So in the third quadrant, what are you seeing with the sign ratio? So the sign ratio, this is our x and this is our y. This is our x and this is our y. So this is our x also and this is our y. So sine theta is always, if this is the angle, this is adjacent, this is the opposite, y over r. But remember, this is negative because the y, are you seeing the value of y you are taking? It is in the negative part of the y-axis. So the sign ratio is going to be negative. What happens for the cos? The cosine is also x over r, but also negative. So what happens to the tan? Obviously, it will become positive. Why? Because you have a negative x and a negative y, so it is y over x, but it is always positive. So it means that in the third quadrant, the sine function will always be negative, and this is from pi up to 3 pi over 2. Angles between this range, they are always going to be giving a negative sign and a negative cos, but the tangent will be always positive. So that's all we can talk about. Let us see the fourth quadrant. The fourth quadrant is this. If this is our radius, this is our y, and this is our x, and this is the angle theta, or if you feel comfortable putting your theta there, this is making it with the none. So this is x and this is y, and this is the point, so x, y. So in the fourth quadrant, what happens to the sine theta? The sine theta is y over r, but y, if you observe y is a negative, then the cosine of theta is x over r, so it is positive 1. Then the tangent is y over x, which is negative. So angles between 3 pi over 2 up to 2 pi will always take on a negative sign and a negative cosine ratio and a negative tan sign. So maybe specifically now we can make a small summary of all what we have talked about. We can make a summary. So if this is the first quadrant, and this is the second, and this is the third, and this is the fourth. So here, all trigonometric ratios are positive, and in the fourth quadrant, it is only the cosine which is positive, and in the second one, we say that the